Kids, it's good to see you again. So, you're a data analyst out in the world writing code to crunch numbers. Here's a question for you. How do you know your code produces the right answer? So it's a seemingly simple question, but it's a surprisingly complex topic. To understand how to even begin answering the question, you're going to need to think hard about a very fundamental question, which at first glance sounds a little bit absurd. Namely, how do you store a number on a computer? So suppose you have some number, like, I don't know, let's say this one. What you see is a string of digits. Each digit goes from 0 through 9, which is 10 possible values. Therefore, we say the base of this string is 10, denoted by little b. Just to be clear, the string you see represents some concrete mathematical value. So to ask for that value, let's enclose the string by a set of brackets. So what does this notation mean? Well, think of it as saying, given a string 1618, blah, 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 give me the number it represents. In a moment, you'll think about number systems in bases other than 10. So let's denote the base explicitly. Next, observe that every digit has a place in the string. Let's number these. In this example, the places or positions go from 0 to 10 since there are 11 digits. Now, given the string, how do you compute its mathematical value? Well, each digit contributes. For instance, consider the rightmost 7. It contributes a value of, well, 7. Now, what about the rightmost 8? It contributes 80 to the final value. And if you continue, what about the 8 that sits in position 7? It contributes 8 times 10 to the 7th power, or 80 million. Now, repeating this process for every digit, the value of the string is the sum of what each digit contributes. 1 times 10 to the 10th, plus 6 times 10 to the 9th, and so on. Generalizing, consider any string of d plus 1 digits. What is its value, assuming the digits are given in base b? It's basically the sum of each digit times the base raised to the digit's position, or more compactly, the following series. Now, I realize this seems like a lot of notation for something that seems simple, but you need a solid and precise foundation to understand how numbers are represented in the machine. Now, let's see how by changing the base. As you probably know, computer hardware doesn't store numbers as strings of decimal digits. Rather, it uses binary digits, or base 2, as you see in this example. So every digit is either 0 or 1. Now, what's the value of this binary string? Well, let's apply the same idea as before. First, every digit has its place. The mathematical value is just the sum of what each digit contributes. In this example, 1 times 2 to the 8th, plus 0 times 2 to the 7th, plus 0 times 2 to the 6th, and so on. At this point, I think you can work out the rest. Now, one more bit of terminology. The term bits is just a shorthand for binary digits, in case you didn't already know. And with that little bit of knowledge, you'll look and sound like a real computer scientist at your next cocktail party, I guarantee. Okay, again, I realize that we started with what probably seems like a really simple idea, and we beat it senseless. But the main concept, which is to think about numbers as strings of digits, is the basic foundation of all digital computing technology as we know it today. So it's a good time to pause and have you do some mental exercises to reinforce those concepts. Now, when you get back, we'll look at how to extend the ideas to represent not just integers, but also real numbers, which I gather is what you need to do all that fancy number crunching.